Good morning. Participants, I think we shall start in 5 minutes, but people who have already joined, if you have any doubt, you can ask me. We shall have discussion. See, many people have made this program. Yesterday's three outputs program, and some people have explored that visualization. They have filled color in timer meter. Very good. Good, Jatin and Sudeep, and many people actually. Many people have made it and sent it. Yesterday also, many people sent it. If anyone has any doubt, you can ask me because today we shall work on PLC hardware. We shall learn today what are the inputs, outputs we use in industry, and how do we make connection with that. We shall learn today how do we work on any new brand. If we make a program in Codesys and the same program we have to make for another brand, uh, what would be our approach? How shall we proceed? That we shall learn. We shall make one project today. I have already connected PLC, AC drive, motor, SMPS, three indicators, two sensors, two push buttons. I have already connected. I shall show you. I shall give you the sequence. I shall give you the conditions you have to make program, and after making program, I shall show you how shall we write that program in Mitsubishi GX developer software, then I shall show you the communication of PLC and laptop or computer. We'll show you how do we send program to PLC and will execute the things live. So today it would be completely, you can say you will get exposure of industry because the things I have connected here all are the real time systems what we use in industry. There is nothing demo kind of thing. It's all real. So today it would be more interesting. I think so. But yesterday we went with timer program. I hope everyone understood that. But still, if anyone has any issue, can ask me.
Sir, good morning, sir.
Good morning.
So actually, for yesterday's morning session, my internet was not working properly. So my codices, I was not able to do the codices part. Later on, I watched the video and tried to do it. And my in my software in my PC, the color is not changing in the visualization thing.
If color is not changing, it means uh, you have not selected alarm color. First thing,
Yes, sir.
second
I have
thing,
selected alarm color.
you have selected. Then you check the address also. What address you have given.
Sir, I have checked the address also. Percentage IX 0.0.
Input color is not changing, right? Switch color is not changing, right?
Yes, sir. Switch color is not changing.
Output is changing.
No, output is also not changing.
That means you have made some mistake. What you do, you double click that switch in visualization. You will get
Hmm.
all options. You said photo, and I shall check that.
Okay, sir.
Okay. Then what I do? Let me start. Coordinators. Shall we start now? See, you had asked question that your input is not working because in toggle variable you have not given input address. In toggle variable you have to give input address. You check that.
Okay, sir. So basically, input is has to be submitted for two things: variable in variable change color also and input also.
Yes, yes. And it is which program you're making this visualization for?
Sir, XOR program XOR.
Timer program,
No, sir, XOR program.
XOR. Okay, okay. Then it's okay. Then toggle will be selected. Yes. Give input
Yeah.
address.
Okay, sir.
Do we have any coordinator? Where are the coordinators? Shall we start? Okay. Okay. Good morning again, participants. Now, as I told, we shall go through hardware interface today. But before starting hardware interface, yesterday some people were interested to know something about off delay timer and pulse timer. So let me show them, or let me show to everyone how does it work. See, on delay timer you understand, correct? On delay timer you understand. On delay timer needs continuous supply to run. On delay timer needs continuous supply to run. Okay. Second thing, as enable is high, as enable is high, its accumulator will start running. Correct? As accumulate as an enable bit of on delay timer is on, accumulator will start running, and we can say timer is running. Now, if we talk about off delay timer, first let me tell you what will happen in that. In off delay timer, as enable is high, in off delay timer, as enable is high, at the same time done bit will come. Try to understand. In on delay timer, done bit came after 10 seconds. If you have 10 second piece preset. In on delay timer, done bit came after 10 seconds. In off delay timer, as enable is high, at the same time you will get your done bit high. But your accumulator will not run. Accumulator will not run in off delay timer. Accumulator will not run in off delay timer. When will it run? When timer enable is off. Once more. In off delay timer, as enable bit is high, at the same time you get your done bit high, but accumulator will not run. And you can say timer will not run. Timer will run when enable bit is off. Enable bit is off. So as enable is off, this timer will run. This timer will run means its accumulator will run. And after 10 seconds, done bit will be off because done bit was on initially only. In on delay, what happened? In on delay, as enable is high, accumulator was running. Timer was on, you can say. In on delay, as enable was on, your accumulator was on, timer was on, and done bit came lastly. In off delay, as enable is high, done bit will come initially, and as enable is off, as enable is off, then accumulator will start running, and as accumulator will finish 10 seconds, done bit will be off. This is off delay timer. I shall show you that in codices also. Then you have pulse timer. Let me tell something about pulse timer also first. In pulse timer, again, as enable is high, at the same time done bit will come and accumulator will start running. But suppose enable is off, there is no problem. Pulse timer requires a pulse event. A pulse event can run this timer. So it does not need to keep your enable continue on. As enable is high, at the same time done bit will come and accumulator will start running. If you off your enable, no problem. It will finish its 10 seconds and done bit will be off. Let me show you that on screen in Codices. Look at the screen, please. So here we have I0 and Q0. I take here one off delay timer, EOF. See, when I have taken off delay timer, I give some name above timer, click outside, make it okay, no change, no change, fine. Huh. So I have given one address above timer, give any name, click outside, make it okay, no change. Left side, I give some preset percent t hash ns 10 seconds. And here let me give A or B, anything, and make it time. So we have done this. Let me show you the same. Log in, run. What I told, as I press I0, immediately this Q0 will get high, but accumulator will not run. Let me show you. Double click, Control F7. See, as I0 is high, done bit has come, but you can see the accumulator has not been running. Accumulator has not been running. As I0 is off, double click, Control F7. See this. Now your this thing. Now accumulator will start running. I shall switch off. You see now. As it will finish 10 seconds, then bit will be off. Got this? So as enable is high, immediately output will be high, but timer will not run. As enable is off, then off delay will start. Okay, fine. Now let me show you this thing for pulse timer. So log out. Pulse timer is also there itself in function block near TOF. I shall type here TP pulse timer. We'll change the name. Okay. Other things we should keep the same. So what I told, that as you switch on I0, immediately the bit will come and it will start running also. But it does not depend on enable. You see, as enable is high, the timer has been running and I switch off I0. You see, I have switched off enable, but still it has been running. Because it is a pulse timer, you can see the symbol of pulse. As it gets a pulse event, means on and off signal, it will start running. So it will start running as enable is high, but it does not depend on enable after that. Okay, any doubt? Tell me, and I shall go for next topic.
No, sir. Thank you so much.
Okay. So now we shall do one thing. We shall start our hardware part. Now change your mindset. Change your mindset. Already you have learned programming part. Though we have many other instructions, we cannot finish all instructions in short term, shorter training. But still, you have understood how we start making program, how we proceed, and how do we finish it. Now, change your mindset. You consider you are in industry. You are in industry, and today it's your industrial project session. So consider you have come to industry, and here you have to see what are the important equipments, what are the important devices, controller, inputs, outputs we use in industry generally. Although all the things I cannot show you here, but maximum things I would try to show you. So when you go to do any project, actually you do not need to be worried about the physical existence of inputs and outputs. For a project programming, you just need to know how many inputs, outputs do we have, what are the addresses, what are the addresses means, where have you connected inputs, outputs to which terminal, those addresses will be required, and the sequence, how the machine will run, that sequence is required. Fine. So I shall start the things with digital input output. First, we need to know that when we go to industry, what would be the inputs, outputs, how will it look like, how will it work. Then we shall go for connection, how do we connect, and then project part. Look at the screen. Here I shall start from digital input. Digital inputs, digital outputs. Analog programming we shall do last day, so don't be worried about that. First, you see digital inputs, outputs, what we connect with PLC directly. What we connect to PLC directly. Now, very first is push button. Push button, you have seen this. It will be NO type, NC type, both.
Yes, sir.
But in all our examples, we have used only NO type push button. Be very clear. About NC type push button, I shall tell you lastly. Today, in last session, in last hour, I shall tell you about this. Because if I shall include NO type push button, NC type push button, both, some people will get confused. So first you make your things perfect with on NO type push button. Then NC type I shall include lastly. So for your information, you will have NO type push button, NC type push button. Generally, green color button will be for NO and red type push button will be for NC. Important thing you see here, behind this, one more thing you should know, when you go to purchase push button, it won't come in assembly, but it will come uh, separate. This upper part you see, this upper part, green button, and this upper part, this is called button. So you need to purchase separate button. So they will ask you how many buttons you want. So button will you have to purchase separately, red color or green color. Then behind this, can you see this black color contact? This is called contact. So they will ask you how many contacts do you want. So this is called contact, and this is the main part. This is the main part. This is your switch, you can say. This upper part is just to operate it, just to press it. But important part is this behind thing, this contact. So separately you will have to purchase one contact. And behind this, you can see you have only one contact. So behind one push button, you will have one contact. Behind one push button, you will have one contact. Fine. So this is a push button. Now next is selector switch. Selector switch, again, upper part is selector, and behind that you have contacts, and you can see we have two contacts here. Selector switch, you have seen this somewhere. It has selecting positions, number of position. Like if it is two-way, one way will be for off, another way will be for on. If it is two-way, behind this you will have only one contact. If it is two-way, behind this you will have only one contact. So once you select, I think I will have this with me. I'll show you, but on screen only you see. So number of position will define how many inputs we get from it. So one selector switch can have many inputs. One selector switch can have many inputs depending upon its selecting points, how many positions it has. Like that, if you have three-way selector switch, on your screen you have three-way selector switch. Middle is off, left side one input, right side another input. So two inputs you will get from this. So you will say you have one assembly, one selector switch, but it has two inputs from it. So two wires will go to two different input terminals of PLC. So many positions, many input, many positions, many input. Another thing, it is toggle type. It is toggle type. If you select one position, it will hold its position. As you select one position, it will hold its position. It will give you continue supply. It will give you continue supply. Okay. And in industry, on panel, control panel, you will find many selector switches, because in a good machine we have two modes, auto mode and manual mode. And when we have manual mode, we will have lot many selector switches to operate manual operation. So selector switches will be used frequently, push button will be used frequently. Selector switch like this you will find many in industry. So many positions, many input. You understood. Many positions, many inputs, and toggle property. Toggle property. Now you see. Next is BCD, binary coded decimal switch. It is also called rotary switch. BCD switch will act like selector only, but it has many positions but limited number of input. It has many positions but limited number of input. It depends on manufacturer, how many positions, how many inputs they have given. But generally, you can say if you have 16 positions, if you have 16 positions, then only 4 inputs will be required. So from 16 position, from 4 inputs only, you can operate 16 positions. 16 positions can be selected. 2 to the power n, it goes like that. So for 16 positions, 4 inputs only will be required. And you can see in this way, you can reduce the number of inputs. I shall give you one example. Suppose you have to select many positions. Excuse me, I shall come. Some people are talking. Okay, so many positions but limited number of inputs. Here you see, suppose you have to select 16 positions. Suppose you have some application where you have to select 16 positions, like you have a drill machine. And in drill machine, you have obviously many. There is one question, selector switch. Okay, I shall tell you about selector once more. See, you have one application. Suppose you have a drill machine, and for that drill machine, you have to start your drill from first position, second position. You have to go for 16 different speeds. So you have to select that. If you have to select 16 positions from a selector switch, if you have to select 16 positions from selector switch, by selector switch, then 16 input terminals of PLC will be required, correct? 16 input terminals of PLC will be required. So number of input terminals on your controller will increase. As number of controller on PLC will increase, the cost of PLC will also increase. In that case, you can suggest to your client that don't go through selector switch, but you go through BCD switch, binary coded decimal switch. What happens in that? You can select many positions, but only 4 or 5 inputs will be required. Only 4 or 5 inputs will be required. Means limited number of inputs will be required. Your PLC cost will not increase. So if you go through selector switches for selecting many positions in one application, cost will increase. Better you go through BCD switch. BCD switch. So what is the difference you understood? Selector switch has toggle property. Rotary switch has also toggle property, but selector switch many positions, many inputs. Rotary switch, many positions, limited number of inputs. So it will reduce your project cost. Okay. So rotary switch or BCD, binary coded decimal switch, you understood. Now this is important. This is important. I want you people to concentrate on sensor, digital electronic sensors. This is
Sir,
important.
1 minute.
Yeah.
In BCD switch, number of inputs we are reducing for 16 outputs. We are giving 4 inputs. What about the outputs from PLC? Input is gone, and from output also only four will go and will work for 16 locations, 16 positions.
Output is different. Output is different part. Input is different part. You see, I shall explain it once more. Wait. Just a see your input, like your rotary switch or BCD
Okay.
switch, it will be connected to the input terminals of PLC, correct? It will be connected
Yeah.
to the input
Yeah. Input.
terminals of PLC, correct?
Yes. Yes, sir.
So on rotary switch, you can select 16 positions, okay?
Okay.
But only four terminals of your PLC will be required, input terminals.
Input terminals. Okay.
So it will just give input signal to PLC. Now it depends on you. By those four inputs, how many outputs you want to generate. It depends on us. So output has no relation with BCD.
Okay.
Got this? Or tell me, if you are confused, I shall clarify.
No, sir. For example, let us take an example of a selector switch, toggle switch, which we saw before. Two inputs we take to them, and two outputs from PLC we take to the relays and we give to the loads. So like that, when I'm giving four inputs with this switch, four
Good.
inputs I'm giving output. I need 16 locations, na? I mean 16 positions of work I need now. So output terminals will increase. Ultimately, PLC size will increase, na?
That will increase, but you see, there is no relation between input and output here. I shall tell you why. Suppose I have one selector switch. I have one toggle switch, suppose.
Okay.
From one toggle switch, I can generate 10 outputs also at the same time. It depends on us. I shall take I0 toggle
Okay.
in our program, and in parallel, I shall take 10 outputs. I can take no.
Yeah, yeah, yes, sir. In software part, na? Yeah.
Yeah, so it doesn't matter. It has no relation with output. It is just one input, like a push button we have taken. That push
Okay,
button I
okay.
connected to the input terminal. Now from that push button input, it depends on me. How many outputs I want to generate? I can do 100 outputs also I can generate from one switch.
Okay, okay, sir.
Okay, so
Yeah.
16 outputs you don't see here in BCD. BCD is generating input only. There is no relation of output because output generation depends on our requirement.
Okay.
Got it?
Got it, sir. Yeah.
Good.
Thank you.
Now everyone will concentrate on screen because sensor is the most. Yeah, tell me. How can I do? How can I adjust? How to adjust? Because you see, is it so? How to do? Okay. Sure, sure, sure. Okay, fine. So you see, uh, you have one sensor here. Now, as we talk about automatic system, in automatic system, more and more sensors will be used. In automatic machines, more and more sensors will be used. Now, sensors we can have of many types. Nowadays, we have sensor to sense anything you want, like color you can sense, wood you can sense, glass you can sense, plastic you can sense, anything you want to sense, you have a sensor for that. But good thing is, when you are going to wire this to PLC, or when you are going to use this in your program, it doesn't matter what is the type or what is the role of that sensor, what will it sense, it doesn't matter. We have the same concept for any type of digital electronic sensor. We have the same concept, universal concept. See here, universally, a sensor, let it be proximity, inductive or capacitive or color detector or metal detector or anything. If you have a sensor, you have to use that with PLC. Very first, minimum three wires will be there. Be very clear about this. Minimum three wires will be there to one sensor. Two wires will be for its power supply. So it's not like that you purchase a sensor and it will start sensing the things. First, you need to power it on. In case of PLC automation, sensor power supply must be 24-volt DC. In microcontroller, we use 5-volt DC sensors. In industrial automation, as I had told first day, standard DC voltage will be 24. So all your inputs, outputs will be 24-volt DC operated, but you can connect directly to PLC. So your sensor must be 24-volt DC operated. Be very clear about that. Now, third wire. Third wire is output of sensor, or you can say it will go to the PLC input terminal. Suppose I have I0 terminal. To I0 terminal of PLC, third wire will go and will give signal. So two wires you have to give positive, negative from SMPS. Third wire will go to I0. Now, another thing, it has universal wire color also. Wire color will be also universal. Positive color. Tell me, what would be the color of positive wire? Tell me.
Red and black
It can.
for negative.
No, no, wait. Only one thing you say. This is for positive.
Red.
It can be
Yeah.
uh, red or brown. Generally you will find brown, BR brown. But red also, you can find. But brown color, remember, always universally, let it be a color detector or metal detector or anything. Its positive wire will be brown or red. Okay, negative wire.
Okay. Black.
What would be the color? Black. It would be blue. Always. Always it is blue color. Always it is blue color. And third wire, which will go to the controller, will be black. Third wire will be of
Okay.
black. Okay. So always remember this. Sometimes you will find, not sometimes, always, you will find it written on the sensor. But if it is not written, if you have old sensor where you don't have any description, then remember, brown color is for positive. SMPS positive will be connected. Blue color wire will go to negative of SMPS, and black color wire will go to the controller input terminal. Controller input terminal. Done. So two things we understood, that we have three wires minimum, and another thing we understood that wire will have fixed color. Okay. Done. I think it is done. It is enough to understand. Sometimes you might have four wire also. We have four wire sensor also. But don't be worried. Four wire if you have, then third wire will be NO type and fourth wire will be NC type. That is it. Nothing else. Other things will be the same. I hope you understand. So sensors you understand. Now, next you can see here frequently used sensor First, you might have inductive proximity sensor. See, proximity sensor means what?
So I just have one doubt here. So in that case, in case of this four-wire terminal, what is this color convention? Is there any global
Ah,
convention?
generally, I have seen it is white color or yellow color.
Okay.
Okay. So see proximity. Proximity means what? Proximity sensor means which can sense the things from distance. That is proximity sensor. Now proximity sensor we can have of different type, like we have inductive type. Inductive type proximity sensor, but let me tell you in industry, in general term, we call when we say proximity sensor, we consider it as a metal detector. In industry, we have some people from industry, they know. When we say proximity sensor, we consider it metal detector. But proximity term is like a sensor which can sense from distance. So when you have metal detector, that would be inductive type proximity. Then you have photo sensor, light emitting sensor, like this. This photo sensor is inductive type proximity. Now you see how does it work. In college you have studied photodiode. In photodiode you have a transmitter and a receiver. A
But
transmitter.
in picture, it is mentioned capacitive proximity sensor, sir.
This is capacitive. Light emitting sensors will be capacitive. And here you see this is metal detector. This is inductive. Okay.
Okay, sir.
So photosensor means capacitive. It is capacitive. When light is emitted from any sensor, that is capacitive. So here on in your college you have studied, you have photodiode. In photodiode we have a separate transmitter and separate receiver. But in industry we use sensor where transmitter and receiver we have on the same face. You can look at the screen. It has been shown. Two two eyes you can see here. One is transmitter, one is receiver. So in photosensor, what happens? As you power it on, 24 volt, you can see the color also. It has been given here: brown, blue, black. So as you provide 24-volt DC to this sensor, it will start emitting light. Generally, it is invisible, light is invisible, but we have sensor where you can have colorful light also. So you can see the range also. You have seen somewhere, I think some people have seen, when sensor is on, you can see some beam, light beam will be visible. And distance depends on you. As per your requirement, you can purchase the uh, that distance capacity, sensing capacity. So it will start emitting light. If any object will cut that light, sensor will be on. So what happens as any object cuts that light, it is reflected back to the receiver and sensor senses it. Uh, it can sense any object, but that object should not be transparent. Be very clear. If you have a plastic, transparent plastic, it cannot be sensed. Transparent glass, it cannot be sensed from photosensor. So it can sense any object, but it should not be transparent.
Sir, again, there is some issues with your voice, sir. I think might.
Is it fine now?
Yes, sir, but some hissing sound.
Yes, sir. Yes, yes.
Okay, now okay, sir.
Okay. So you understood. We use inductive proximity sensor, which is metal detector, and its sensing range will be 3 mm to 8 mm. 3 mm to 8 mm. Although its range can be varied, but generally we use low sensing range metal detectors. Low sensing range metal detectors for precision. Next, in industry, you will find one more sensor magnetic reed switch, we call it. We call it a reed switch, REED, reed switch. Magnetic reed switch. This is also used frequently. But where do we use this sensor? And you can see this sensor is two-wired sensor. It is two-wired. It is not three-wired. It will work like a push button or toggle switch. We have two wires in push button toggle switch. Okay, that you leave. Wiring I shall tell you further. But you see here you have two-wire sensor, that is reed switch. It is magnetic. Do anyone does anyone know where do we use this magnetic reed switch? Where do we use this reed switch? Can anyone tell me?
In railway tracks.
In
Sir,
industry,
in laser cutting machines,
is it so?
yes, I use that.
Oh, very good. I did not know actually. Can you tell me something more about that?
Sir, in
Sir,
the railway tracks, while the train movement for sensing the train movement with the vibrations of its effect on it.
Okay. And
sir, in that fabrication industry, the part is cut by the laser. That can be part on putting on the laser machine that can be kept by that magnetic sensor.
okay, okay, fine. So I
मतलब
did not know.
ये बताना चाह रहा हूँ कि सर जो पार्ट रखते हैं तो मैग्नेटिक सेंसर की वजह से वो वहीं पे फैला है तो
Come
कटने
again,
में
please.
तकलीफ होती है इसको पार्ट को
Once more.
सर जो मैग्नेटिक जो जैसे कि हमने कोई भी पार्ट रखा जिसको हमको लेजर मशीन से काटना काटना होगा तो उसके ऊपर ये तो वो पार्ट इसके ऊपर रखते थे जिससे कि वो पता पड़ जाता था मशीन को कि ये अच्छी तरह से पुट हुआ है या नहीं हुआ है
Okay, fine, fine. Okay. One application I shall also tell you. What you will find in industry generally. Many people are from mechanical. You know, you use pneumatic systems, correct? Pneumatic cylinders. And in industry, we have a lot many applications based on pneumatic cylinders. Pneumatic cylinders, again, we have of many types, of different types. You can have single acting, double acting, then its piston can be magnetic, non-magnetic. Generally, we use magnetic pistons. So what happens, just consider, okay, I shall show you on screen also. You see this. Suppose, presence please, these are very important information you must know before you go to industry. So you see, if you have a cylinder, pneumatic cylinder, I won't go in its detail, but pneumatic cylinder has a piston inside it, correct? It has a piston which moves and it is operated by compressed air. It is operated by air. So if it is double acting, suppose it is double acting, you will have two valves here, solenoid valves. One valve will be for inlet, another will be for outlet. Means one valve is on, it will go forward, another valve is on, it will be reversed. This piston will be reversed. Now suppose there is one workstation where we have put one joint drill it. Obviously, before drill, we need to clamp it. If we don't clamp, the drill will not be proper. So from PLC, one signal should go to this. Suppose this is Q0 and this Q1. And here we have I0. If I press I0, Q0 is on. Suppose it is for forward, it will start moving forward. Obviously, it will not move with high speed. It will go slow. As it goes slow, PLC needs to know whether it has clamped it or not. So PLC needs feedback from this piston, from this cylinder. So what happens? Its end is magnet actually. Piston end is magnet. So you have magnetic field here. So reed switches, magnetic switches, this is very small in size. Two reed switches will be used. One home position signal and one for final position. Suppose When it clamps, this magnet reaches to this point. So what happens? As you press I0, Q0 is on. As this will start moving and will reach here, your suppose magnet reaches here and reaches here. So that time this will be off and this will get on. As PLC will get this signal, PLC will come to know, okay, it has clamped it and now it will start drilling. So magnetic sensor will be frequently used on pneumatic cylinders. On pneumatic cylinders. Now you will say we have hydraulic cylinders also. For hydraulic system, you cannot use magnetic sensor because we have viscous oil there. Correct? We have oil there inside this cylinder,
Yes,
so
sir.
we won't have good effect of magnet. Yeah, we won't have good effect of magnet. So we use there that proximity sensor, metal detector. What we do generally, we place some metal to this piston and we put two metal detectors, one for home position and one for final position. So in hydraulic system, reed switches will be considered your magnetic metal detectors, and for pneumatic system, your reed switches will be magnetic reed switch. Okay, done. So that you understand. Reed switch done. Now you see one more switch is there, that is limit switch. Limit switch. Limit switch is also used frequently in industry. I shall give you some example and you will understand it. See, I shall take questions lastly. I'm seeing some questions are coming. I shall see all the questions lastly. First, let me finish. Limit switch is considered a mechanical sensor because limit switch senses the position of heavy moving job. For example, elevators, lift is very heavy and it is moving, and on each floor it has to stop. You have experienced that when lift will start, it will start with high speed, and as it will be about to reach, the floor, it will be slower, and after that it will stop. So what happens actually, if you see on the screen, you will have your lift here, you will have lift on and it will move on the rail. These two are the rail on which your lift will move. Suppose this is the floor and it is coming from up. So one limit switch will be here and one limit switch will be here. So as lift will come, it will strike this first. As it strike, as it strikes first limit switch, signal will go to AC drive. AC drive will give signal will go to PLC or the controller, and controller will send signal to AC drive, and AC drive will make that motor slow. As it strikes final read switch, limit switch, as lift will strike final limit switch, again signal will go to controller will send signal to AC drive, and AC drive will stop the motor. So here you see your lift is heavy moving job, its position needs to be sensed. For that we use limit switch. You will have conveyors like automobile industry or any big industry, you will find uh, conveyors. On conveyor, suppose some heavy material has been moving, or in automobile industry, car manufacturing industry, your car chassis will move on conveyors, and on different position it needs to be sensed. So for that you cannot use proximity sensor or photo sensor. You have to use their limit switch. If you will use proximity sensor, then sometimes it will, not sometimes, frequently it will stop. So here you have to use limit switch. So remember, whenever you have to sense the position of heavy moving job, there you have to use limit switch. See this limit switch. can be striked from other side. It can be striked from other side. From this side also it can be strike. From this side it can also be strike. As it is a strike, it will change its position and signal will be high. Okay, done. Then you have level switch also. Level switch will be used to sense the position of material in the tank. It won't tell you the quantity. It won't tell you the quantity. Quantity can be measured by analog analog level switches, level sensors. But limit switch, you just try to understand. Limit switch is digital. It will just tell you the position. It won't tell you the quantity. So floating, generally floating, you can see this is floating and this will also float. This will also float up and down. So you have limit switches also frequently used in industry. So these are the inputs. These are the inputs. Now I shall take the questions regarding input. I will check some questions have come in WhatsApp also. You can ask me question, no problem. By 16 position, do we meet the output in case BCD switch? I think the same question. You can ask if you have any question.
Hello.
Yes.
Sir, please explain BCD switch with an example.
I told you, no. One example I told, like we had changed one manual operation to automatic system, and there we had seen for speed selection. For speed selection, we had many positions. For speed selection, we had many positions. Like you consider we have a drill machine, and that drill machine has different speeds, and those different speeds were operated by some clutches. So the concept was we removed the manual connection and that mechanical arrangement we removed, and uh, we thought to have some selection instead. So for selection, we needed 18 positions actually in that case. So when we had to select 18 positions, suppose you select first position, first drill will run in first speed, then second position it will run in second speed, third position, third speed, like that. We had to increase the speed. But if you take selector switch for 16 positions, if you take selector switch, you understand. Selector switch will have many positions, many inputs. So if I have to select 16 positions, I will have to use 16 input terminals of a PLC, because selector switch will give one position, one input, will give one position, one input. So we needed to use 16 inputs. If you use 16 inputs for selection only, you have another inputs also in your project. So your input terminal will increase and PLC cost will increase. So what we did, instead of that, we took BCD switch. So BCD switch, for example, if it has 16 position, it can vary also. If you have 16 positions, you will select first position. You have 4 wires from BCD which will go to PLC input terminal. Only 4 wires. You have 16 positions on BCD, but only 4 wires will go to PLC input terminals. Now for each position, like you select first position, second position, 10th positions, 15th position. For different position, we have combination of four inputs. Suppose I0, I1, I2, I3. So on its catalog, it will be given for position number one, which input you will get. For position number two, which input among four you will get. For position number 10, which input you will get from four inputs, four wires. So you will have to check that in catalog. So for each position, you have combination of four inputs. Some inputs will be on, some input will be off. Like that, it works. So here we have to understand only the thing that if you have to reduce the number of terminals in case of selection, then you go through BCD.
Okay, sir, got it.
Okay. Anything else? One question has come. Magnetic reed switch properly. Okay, I shall repeat it once more. See, magnetic reed switch is frequently used on pneumatic cylinder. You see, first you try to understand the application. The application is when this piston will move, I need to know whether it has reached to its final position or not. The application is when this piston will move, it reaches to its final position. When it reaches to final position, I need to know, PLC needs to know it has reached here. Then how shall we come to know? If you want feedback, feedback is some digital input. So what happens? This magnetic piston, this pneumatic piston, this pneumatic piston will have magnet on its end. Pneumatic piston will have magnet on its end. Again, I shall tell you, you will have to purchase that type of piston because we have magnetic piston, non-magnetic piston also. So you should have that magnetic piston. It will have magnet on its end. So if it has magnet, you have magnetic field here. When it has magnetic field, you can place one magnetic reed switch here, magnetic reed switch. And this reed switch will sense the magnetic field and will give signal to your PLC. Will give signal to your PLC. One piston one reed switch we put on final position also. Like when piston moves, reaches here, suppose this magnet comes here. So when this magnet comes here, this reed will be on, this will be off. So now this signal will go to another terminal of your PLC and PLC will come to know, okay, I1 has come, it means it has reached to final position. Okay. Another.
Excuse me, sir.
Hmm.
Sir, we can achieve this work of read sensor with the help of proximity sensor also. So means why we are using proximity? Why we are not using proximity sensor but using read sensor? Sir, what's the main difference?
See, see this, the first thing is it will give you more accuracy because it would be fixed, it won't get any vibration and all, and due to vibration it won't move. Proximity sensor generally get a problem when we have vibration and all, its position is moved and it stops sensing because its sensing range is less. Second thing, your pneumatic cylinders you might fix somewhere where you cannot put one proximity sensor because sometimes this piston will go inside the machine where you don't have space to arrange that proximity sensor metal detector. So arrangement of metal detector will be a task if you use that. And when you have this reed switch on pneumatic cylinders, we have slots given for reed switches. So it is very easy to use and will give you more accuracy. And we have seen many times, like in machines and gantry systems, wherever you use a proximity metal detector, it senses in 3 to 8 range. And if because of vibration it moves slightly even, it will stop sensing and your machine will stop. So in case of pneumatic system, better you use uh, magnetic sensor. See, we can do anything. In India, we have Jugaad system, you know now. We can arrange anything. But it is better to use the proper thing with the proper device in proper application also. So it depends on application, which device we are using. According to that, we should select the proper input. Anything else?
Okay, sir.
See, proximity sensor, capacitive and inductive. See, inductive, generally you consider inductive sensors will sense metallic jobs, and proximity capacitive sensors will be light emitting sensors. So wherever you have sensor which is emitting light will be capacitive generally, and when you have metal detectors, it will be inductive generally. Okay, fine. Using reed switch, we can vary the stop length also. It depends on your sensor. If you have your uh, no, not depends on your sensor. It depends on your cylinder. If your cylinder has that facility where you can have that different position and different on different position you can stop it. You can use multiple reed switches. You can use multiple reed switches. Okay, now
Hello.
yes.
Sir, one more question. Sir, how can I get to know that which sensor must be used for a specific application? Means
See,
many times
for,
we get confused that which sensor must be used here and there. So,
see, I told you, if you have to sense metallic uh, jobs, generally proximity inductive will be used. Okay. And when you have pneumatic systems, magnetic reed switch will be used. When you have uh, to sense any other objects, like not magnetic and all, and not metallic, any kind of job you have to sense, or you can say it totally depends on your application. Like if you have to sense some, if you have to count some jobs, suppose if you have to count some jobs, if you have to count some people, then you go with photo sensors. And if you have heavy moving job, I told you, you have conveyor, suppose on conveyor some trolley has been moving, and there if you will use proximity metal or proximity photo, then you will have problem. Why will you get problem? We had faced one problem in one industry. They had trolley, and they had used that a metal detector. So because of vibration on that conveyor, always it used to stop sensing the trolley, because of vibration the position of sensor used to move, and when it was moved, it used to stop sensing and machine used to stop. So when you have heavy moving job, I told limit switch you use. When you have to sense color, obviously color sensor you will use. When you have metal, then that metallic sensor inductive you will use. So like that, as per your requirement, you will have to select your sensor. And let me tell you, anything you want to sense, as I told you, some people are from Bosch lab. You have Bosch lab in your college. In Bosch lab, they have all kind of sensors, and there I have seen they have sensor where they can sense color, they can sense plastic, they can sense food, they can sense glasses. everything. So in your project, if you have such a application requirement, according to that, you select your sensor. But I told you some frequently used sensor in general industry, in manufacturing industry, that magnetic metal detector, capacitor, and reed switches. Sometimes color detectors also you will have when you have packaging machines. Okay, fine. Shall we move?
Yes, sir.
So you see, in academics, generally we don't know about all these things. If you know, it's very good. But I have visited many colleges and I have found that generally we don't know about all these inputs. And I have seen mechanical people, they have to work on pneumatic hydraulic systems, but in many colleges they have not knowledge of this reed switch, because we are not using in college. In industry we have using that. So it's good you learn about all these things initially when, before going to industry. Now I go for output, digital output. So some questions I shall ask, you have to answer, and you can also ask me question. So very first, one digital output you can see here is lamp or indicator. Lamp or indicator. Be very clear, Mike. Be very clear that all your outputs will be 24 volt DC operated. All your outputs will be 24 volt DC operated. So this lamp is 24 volt DC operated. This lamp can be connected to PLC output terminals directly. This lamp can be connected to PLC output terminal directly. Though you can find this lamp of 230 volt AC also, but with PLC you have to use DC type, 24 volt DC. Now you see here. Just a minute. Actually, I am in college premise. Some people have been talking. Okay. Now it is okay. When someone talks, I get disturbed. Fine. Now you see, interesting thing. I told we can use 24 volt DC outputs. We can connect directly to PLC output terminal. But in industry, obviously, we won't have all outputs 24 volt DC like motor. We won't have 24 volt DC motor to operate our machines, our work. It will be single phase or three phase, correct? First, let us have discussion about single phase. If we have single phase output, suppose you do some project in your college and you use some pump, single phase pump, or you use that fountain pump also, that is in aquarium, that is in cooler also, that is 230 volt AC. So if I have to operate, if we have to run that pump, 230 volt AC pump from PLC output terminal, we cannot connect that pump directly to PLC output terminal. Be very clear about it. So your single phase 230 volt AC output will not be connected to PLC output terminal. That is not the output of PLC. But that will be getting signal from PLC only. In that case, remember, we have to use a relay. And this relay should be 24 volt DC operated. Tell me, you people, what is relay? What is relay?
It's a magnetic coils, just giving supply for the contactor for on and off or close or open, whatever.
Okay, so relay is generally a switching device, right? It can have different type. You have studied in college. You have many type. Some people say it is safety device and all. Everything is correct. But in general, if you talk about relay, relay is an electromagnetic switch, or people call it electromechanical switch, correct? So I'm talking about electromagnetic switch, electrically operated switch. Very good. So electromagnetic switch I'm talking about. So you must have a relay if you are going to operate a single phase AC device. Be very clear. You must have a 24 volt DC relay if you have single phase AC output. Now we shall have discussion about this relay, you see, and your concept will be very much clear on your screen. Look at this, and I shall give you time to ask question. It must be very clear. In microcontroller we use 5 volt DC, but here you have to use 24 volt DC because PLC output terminal is 24 volt DC operated. So suppose you have a lamp 230 volt. You have a lamp 230 volt AC, and this you need to get on by PLC. This you need to get on by PLC. So what you have to do, you see here, its wiring connection will be the same what you had earlier. You remember this. It requires line and neutral. It requires line and neutral. And do you remember where did we connect the switch first day? You remember where do we connect the switch? We connect the switch in line path. I hope you understand this. This is clear. So this is a lamp, or it can be a pump or motor. It will get line and neutral as we get generally. So general wiring, normal wiring, and we can connect a switch in line path. Now this switch is manual switch, correct? This is manual switch. A man needs to operate it. But our requirement is now it should be operated by PLC output. It should be operated by PLC output, not manually. So very first you should make your wiring diagram like this. When you use it in your project for wiring, very first you should make a wiring like this diagram. After that, you can replace this manual switch with a relay like this. See, I'm going to replace this switch with a relay. So what do we have in a relay? We have a coil, and we have one iron core. To this switch, we have spring system. Now this relay coil is 24 volt DC operated. Okay, 24 volt DC operated. This coil will become your PLC output. PLC output. As PLC output will be on, this coil is connected to PLC output. It will get 24 volt DC. This magnet will be magnetized. This iron will be magnetized, and this metal part of the switch will be attracted. As it is attracted, you can see lamp will get line supply, and it will be on. Now this output is off. PLC output is off. It is demagnetized. It is demagnetized, and due to spring system, this contact will be open. Due to spring system, this contact will be open. Is it clear? Is it clear, everyone? Is it clear the concept? How do we use a relay
Yes, sir.
between output and PLC? Okay, fine. When you purchase a relay, actually you will have 1, 2, 3, 4, 5 minimum terminal on it. Let me tell you what are these terminals and where do we have. Suppose I give number. This is number 1 terminal, this is number 2 terminal. So these two terminals we have for PLC connection, for coil. Next, consider this is your 3 number, and to the relay you will have one more terminal here. So this is your fourth number, and this is your fifth number. Correct? So you see here, 1 number, 2 number, these two will get, see, number can get changed also. It is not fixed. You need to check on relay. So these two will get power supply from PLC output, and 3 number, 4 number, these two are NC type, isn't it? 3 and 4, these are NC type, means what? Already number and 4 number are connected. But 3 number and 5 number, you see, 3 number and 5 number, these are NO. You can see 3 number and 5 number, these two are open now. So when coil is on, then 3 and 5 be connected. I hope you understand. If you have any question for this diagram, you can ask me. Is it clear?
Yes, sir.
Okay. Fine. So you have to remember that you need one relay when you have single phase AC output to be connected to PLC terminal. On your screen you can see we can have sensor like relay like this. We can have relay like this also, which is transparent. You can see the coil and the contact. Okay, I shall proceed. So this is single phase. Okay. Now, anyone wants to ask question? No, I think. Okay. So you have to answer me. In single phase, we have one line, correct? In single phase, we have one line, one phase, you can say. In three phase, how many line wires do we have? In three phase, how many line wires do we have? In three phase, how many line wires do we have? See, in single phase, one line wire is there. In three phase, we will have 3 line wires, line 1, line 2, and line 3. So you answer me. Yes, correct. Three line wires we have. So if for one line we have used one relay, correct? For single phase we have one relay. For three phase, what shall we do? For three phase, what shall we do? For three phase, what shall we do? In three phase, we have 3 line wires. In three phase, if we have 3 phase motor, what shall we do? For single phase, we have used relay. For single phase, we have used one relay. For 3 phase motor, what shall we do? 3 relays use. Okay. Another. Okay. Scholars on GMeet, tell me. For 3 phase motor connection, what shall we do? See, it doesn't matter you are from mechanical or from electrical or from EC or from instrumentation. You have to work on these systems in industry. Okay, so I shall tell you. If you have a 3 phase motor, and in industry we have more and more 3 phase motors. Though nowadays we connect motors to, one person has given correct answer. We have motors, three-phase motors in industry. We connect that to drives. But leave drive now. If you have three-phase device, yes, Kannan sir, correct. If you have three-phase device, when you have three phases, then you have to use a contactor. Contactor. See, electrical people, mechanical also. In your college, you go to lab where you have motor and electrical guys. You already have studied star to delta switching. In star to delta switching, you have three contactors there. If you will check, one is for motor, one is for star, one is for delta. So contactor, it will look like this. Contactor will be used when we have three-phase appliances. Now this contactor is also electromagnetic switch. This three-phase this contactor is also three-phase. Sorry, I'm reading something. Okay. So this contactor is also electromagnetic switch. You can see here. In electromagnetic switch, here you can see you have three contacts. Actually, these three will be connected with each other with insulator. I have not connected. This is missing. So line 1, line 2, line 3, and one coil. Again the same thing. As this coil will be high, magnet will this iron will become magnet, and all three will be attracted at the same time. All three will be attracted at the same time, and contactor ampere rating will be very high. Relays, if you will use with three-phase devices, relays will get burned because generally relay ampere rating will be very low, and your contactor ampere rating will be 40 ampere, can be more also. But generally, I have seen it will be 40 ampere, and it will be used when we have three-phase appliances. Okay, so you understood any output operated on 24 volt DC can be connected to PC output terminal directly, but still it should not be of very high ampere rating appliance, because sometimes we have some motor which runs on 24 volt DC, but its ampere rating will be high that you don't connect directly to PLC output terminal. So PLC output terminal will accept 24 volt DC lamp or indicator. It will accept 24 volt DC relay. It will accept 24 volt DC contactor. And there is one more output of PLC, that is solenoid valve. Solenoid valve, or it is also called electromagnetic valve. Electromagnetic valve. I think some people who have worked on hydraulic pneumatic system, you have seen these valves. Correct? You have seen these valves. So this solenoid valve is 24 volt DC operated, and it can be directly connected to PLC output terminal. And this is 24 volt DC operated, and you can understand here pneumatic system and hydraulic system are the outputs which are operated by PLC in industry. And you can see they have given 24 volt. Standard voltage of these solenoids nowadays will be 24 volt DC. Initially we had 9 volt also, but nowadays when you purchase hydraulic pneumatic system, it would be 24 volt DC operated. So I hope you understand inputs and outputs, what we connect with PLC directly. So these should be 24 volt DC operated. I want you people to have rest for 2 minutes. Don't go anywhere. Revise the things, take rest, have water, and ask question. Yes, some relays are there which will have three terminals, like three contacts parallel connected. But I told you cannot use those three contact relay in three-phase device, because what happens generally, these three-phase motors we use to operate heavy load like some grinder or some mixer or air. So what happens when you start the motor? As motor will start, initially load will increase. As load will increase, ampere in the wire will increase, and it will generate heat and all. Your relay contact will get burned. So relay will not have high ampere rate. So contactor is the proper device we use with three-phase appliances. I did not understand. You are asking transition type. I did not understand the question. Okay. I hope you people have understood what we have finished till now. So if you have any doubt, you can ask me anytime. But let us proceed because we have to do many things today. Okay. Fine. So might be today it will be a bit boring because today it's I am only talking. You people are not having any task. But please manage because these are very important things to know when you go to industry and you know about all these things. There, people would be very happy. They will welcome you. So you should know about all these things. Okay. And I'm sure many new things you have understood, you have learned today. And further also you will learn. Now, next, all these things you understood. Now it comes when you are making a project, how will you wire all these inputs, outputs, digital inputs, outputs to PLC input output terminal? That is again one important thing you need to know. And if you have visited industry, might be you have seen the control panel. Inside control panel, you will have lot and lot wires. And there you might get confused. How did they wire and all? See, there we have a lot many wires, but wiring concept is for all 100 inputs or 500 inputs for 1000 inputs. The wiring concept is the same. So once you learn the concept, it would be very easy for you to do wiring for your project also. So let me tell you about wiring now. Concentrate. Wiring, PLC wiring we have of two types. PLC wiring we have of two types. Sink type, source type. Sink type, source type. I have found people come from industry for training. They work on PLC, but they are very much confused about wiring of PLC. And this is why, because we have two types of wiring, we get confused in sink type and source type. Keep patience and listen to me. Sink type, source type. It depends on manufacturer. It is not fixed that always input will be sink or output will be source, or input will be source, output will be sink. Not like that. It depends on manufacturer. You will have to check the catalog. In catalog, you see whether your inputs are sync type or source type. Your outputs are sync type or source type. Then, according to that, you have to do wiring. Okay. When it is sync type wiring, in catalog I had seen, we call it hardware manual, connection manual. When you see the connection manual, you will find it is written, try to understand, it is written in case of sync type wiring, wire in such way that the direction of conventional current should be towards PLC. This is the thing written in the manual. What is this? If you have to wire in sync, suppose your push button, connect your push button in such way that the conventional direction of current should be towards PLC. And I understand that many people will get confused here. If you have to connect a push button, you will have to imagine, okay, what would be the conventional direction of current? And you will have to think like this for all inputs. So people get confused because of this, and vice versa for source type. Connect in such way that its conventional direction of current should be outside of PLC, not inside. The direction of conventional current should be outside of PLC. That would be source type. But if you want to eliminate the confusion, you want to remember this always, you do one thing. Actually, some people are talking again. So give me 1 minute. Again, I shall tell them to keep quiet. Okay, sorry for inconvenience. So if you want to remember this sync source concept, remember this. If you have to connect in sync, think nothing. Just connect your input or output in positive, in between positive wire of SMPS itself, it will be sync type. So you have to think nothing. As I told, sync and source is applicable for input connection and for output connection both. So if it is sync type wiring, you connect your input device or output device in between positive wire of SMPS in the same way that you did for a switch connection in between line path. That is sync type. So in PLC wiring, you have SMPS, 24 volt DC. So you connect your input device or output device in between positive path of SMPS. Remember this only, your wiring will be always correct. Now source type. Obviously, when you have to do source type wiring, your input or output must be connected in between negative path of SMPS. I hope it is clear. Answer me please, you people. Is it clear? sink and source concept. Think nothing, just remember, if you have to connect in sink, connect in between positive path. If it is source, connect in between negative path. Yes, very simple. And people used to come from industry to learn wiring specially, and when I used to say this concept, they used to say, see, for this simple thing we came here. So this is important. It doesn't matter which definition or which explanation you read in book. It is important what we can remember all this, and you will remember this all this, I hope so. So sync source is clear. So first concept is clear. Sync type, source type of wiring, it is clear. Second thing, very first I shall ask you one question, and then I shall tell you about the second point. So first point, you have understood type of wiring, sink and source. Second thing, you people have to answer. You people have to answer. If we have, clear, okay. If we have one PLC, listen everyone, and answer me. Everyone has to answer. We have a PLC and we have output terminals. We have output terminals. Suppose here it is Q0, Q1, Q2, Q3, Q4, and common will also be there. Now, suppose there is a program inside PLC and your Q0 gets high. Listen carefully. There is a program inside PLC and we have Q0 coil. We have Q0 coil, and this Q0 coils get high inside your PLC. So obviously your Q0 terminal will get high, correct? No? Your Q0 terminal is high now. When this Q0 terminal is high, you have to check voltage across output terminal and common terminal. Got it? Once more, listen everyone, scholars, students, faculty, everyone, listen and you answer. This is the question will be asked in interview. If we have a PLC and we have not connected any output, you see, nothing we have connected. We have just simple output terminals. And we have sent one program inside PLC. In that program, Q0 gets on by any means. If Q0 is on, Q0 terminal will get high. Q0 terminal will get high. Now take a multimeter and check voltage across output terminal and common terminal. What would be the voltage here? Tell me. Everyone answer this please. What would be the voltage across output and common terminal when PLC output is high? Answer please, everyone. Everyone, answer me please. This is important question. 24, okay. Tanish, positive path I had told previously in wiring type. Positive path means positive wire. Okay, scholars who have been attending through Google Meet and faculty members who have been attending through Google Meet, tell me, when the output is on, output terminal is on, we have not connected any output, there is no wiring here, we just check voltage across output and common terminal. What would be the voltage here? Okay, very good response. Very good response. Many people have texted and all have texted 24 volt DC. Nice. If output is 24. Okay. Correct. Everyone is correct. You are correct because what you are thinking is correct actually. As I told, PLC output terminals are 24 volt DC operated. So you told we will get 24 volt DC. Note down please. First point you have noted down sink source. Second point you note down. This is important. Second point you note down please. Second point you note down. See, input output we have separate. We have separate wiring for input, separate wiring for output. And in input also we have 24 volt DC operated, output also 24 volt DC operated. Now you see, note down please. When output is on, write down, when output is on, we do not get any voltage. When output is on, we do not get any voltage across output terminal and common terminal of PLC. When output is on, we do not get any voltage across output terminal and common terminal. It is potential-less. These terminals are potential-less. There is no any potential across the terminals, across terminals. So it is clear. We shall get 0 volt. This is interesting, isn't it? We don't get 24 volt DC across these two terminals. These terminals are potential-less. We don't get any voltage. But you can write down. We don't get any voltage, but we get continuity across output and common terminal. We get continuity across output and common terminal. We get continuity across output and common terminal. It means there is no voltage if I say this and this, output terminal and common terminal. There is no voltage across these two, but we have such type of contact. So we will get continuity. These two will get short actually. These two, Q0 and common, will get short. It won't give you any voltage. It will give you continuity. So you can say PLC output terminals will act like a switch. PLC output terminal will act like a switch. Okay, let it be. I hope you understood that we have no voltage, we have continuity. Further, I shall explain you how do we get continuity and all. Further, I shall tell you. So two concepts clear, that sink and source type connection. Second thing, we don't have any voltage across the terminal. It is potential-less. We get continuity. Okay. Third thing you should always remember, we must have one SMPS. We must have one SMPS with us while wiring, because you have seen there is no voltage on terminal. There is no voltage on terminal. So we must have one 24 volt DC SMPS to wire input output. We must have one SMPS. This is it. Third. This was third. We need one SMPS. Okay, done. Now I shall show you how do we wire our push button, sensors, switches, relay, how do we wire lamp, all these things I shall show you on screen, and now you will understand it better. Suppose we have to connect input in sync type. Sync. So input we have to connect in sync. So I am taking here some input terminals. These are some terminals. Consider this is I0, this is I1, this is I2, I3, and common terminal. So this common name will be different for different brand. Don't be worried. Work is the same. Sometimes it is CC or V or another name also. No problem. SS also will be there. So when you do wiring, you must have one SMPS, correct? You must have one SMPS, positive, negative. Now you see, if you give positive if you give positive to input I0 and negative to common, this I0 terminal will get high, correct? As you give positive to I0 and negative to common, this I0 will get high. But we want to give signal through some switch. We want to give some signal through some switch. Okay. Now consider we have one push button. We have one push button. We have one push button. And we have to wire this to I0. See, it doesn't matter which kind of switch you are going to connect. It can be a push button, it can be a selector, it can be a BCD, it can be a sensor. So you can have reed switch also where we have two wires. So while wiring, you categorize inputs. While wiring, you categorize input. Two categories. First will be having two wires and second will be having three wires. Got it? So when you do wiring, you don't be worried what is the use of that input or how does it look like. You don't be worried. While wiring, you see how many wires do we have. Got it? While wiring, you see how many wires do we have on that input. Here, we have categorized two wires and three wires. First, let us do wiring of two wires. So this is a push button where we have two wires and we have to connect in sync type. When we have to connect in sync type, to which path should we connect? Tell me please, everyone. We have to connect the push button in sync type. To which path should we connect?
Positive, between the positive wire.
Yes, between the positive wire, since it is sync type. So you can do one thing, you can break this positive wire. You can see, no, you can break this positive wire and you can place your push button in between. So now you see your push button is in between positive paths. If you want one more, see, if you want one more push button and you have to connect in sync, one wire will go to input, another will go to positive. It is in between positive path, isn't it? It is in between positive path. Correct. Done. Now you see, you have to connect three wire input. Suppose sensor. Now we have to connect a sensor. Sensor has three wires, and you know black wire will go to input, red or brown wire will go to positive, and blue wire will go to negative. This is the wiring concept of PLC input. In this way, let it be any number of inputs, 100, 500, no problem. You can wire in this way. This is the concept, nothing else. Note this down and ask some questions. If you have any doubt, you can ask me question. So I told you either 2 wires or 3 wires. You will have on input and wire like this. Okay, you can ask me question. Okay, done. One more thing you should know here about sensor. If it is sync type, this is important. You see, you people will use sensor in your project. You people will use sensor in your project. So you should remember this. If it is sync type connection of input, then your sensor must be PNP. Your sensor must be PNP type. If you have to connect your inputs in sync type on your PLC, you will check, okay, inputs are sync. Then your sensor should be PNP type. Your sensor should be PNP type. And when it is source type inputs, then it would be NPN type. So this also you need to know. When you purchase sensor, you have to check your PLC. PNP type and PN type. So PNP will be used when it is sync type. When it is source type, then NPN. And obviously when it would be source type, then potential will be changed. You have to interchange positive, negative. And that concept also you see, the conventional direction of current. It is positive to negative, right? It should be towards PLC, you see, positive to negative. So you can see the conventional direction of current is towards PLC. It is towards PLC. Okay. Now done. I shall remove this and will show you PLC output. Okay, I won't remove here only, I shall make. Now it is PLC output wiring. It is very simple, you see. Now we have PLC outputs like Q0, Q1, Q2, and common terminal. Sometimes you will have many common terminals, few outputs common, few outputs common. So all common terminals you can short through some wire. Now you see, if you have a lamp or indicator, if your indicator is 24 volt DC operated, you need one SMPS, the same SMPS you can use. Tell me, if it is source type, output, then to which path should we connect this lamp? To which path should we connect this lamp? When it is source type, to which path should we connect this lamp?
Between negative wire of SMPS.
Yes, so it is negative. So it will go to negative, and here you can see it is connected. Obviously, common will get positive this time. Common will get positive this time. And if you have one motor single phase, suppose 230 volt, then how will you connect? You need a line, you need a switch, it will go to this, and it needs neutral. But now this switch will be your relay, and this relay connection, you see how will we do? How shall we do? 2 wires we have in relay, so will go to output, another will go to negative. That is it, nothing else. It's very simple. Note this down. You can note this down. Okay, so finally, digital inputs, outputs, and its wiring we have finished. If you have any doubt, please ask question. Any kind of question you can ask me. There is no issue. Don't feel hesitation.
Sir, how we use three-phase motor?
On three phase, you will have like that only. Like instead of this one contact, you will have three contacts. Instead of one contact, you will have three contacts. So here you have one line. There you will have three lines, and connection will be the same here. You see, your contactor will also have the same kind of coil, 24 volt DC. It will be connected to PLC like this one. Even your solenoid valve will also be connected like this. So you have to see this part when you wire to PLC. Two wires, you see, two wires of this, because this is 24 volt DC coil. Lamp is 24 volt. We have connected directly. Solenoid valve, if you have solenoid valve, that will also have two wires. One will go to output, one will go to negative, like that. Okay, one more thing I shall tell you. It would be interesting. I hope you have noted down. If you have not noted down, in the evening you can see the video and can note this. I shall remove it. I shall tell you why we don't get any potential. Why we don't have potential, you see. First today you remember, no, in block diagram I told it would be relay type or transistor type. So each terminal will have a relay on it. Each terminal will have one small relay on it. So this is your common, and this is your Q0. Just a minute. So it is your Q0. So what happens actually, on each terminal we have a relay like this. We have a relay like this on each terminal. And you can see these two are connected. Now, if you have a lamp, you see, if you have a lamp and you connect this and you connect to this, what will happen? When this Q0 is high, it will be connected. Then these two will be short, and this short cannot get this lamp on, correct? This short cannot get this lamp on. So what we do, we put one potential here. That's why you have seen you have one SMPS, positive, negative. So one wire will go to negative, one will go to positive. Now you see, if this relay, this terminal relay, as Q0 is high, this Q0 terminal relay is high, and positive will go to lamp and negative is here. So loop will be made, it will be on. Is it clear? Is this clear, this concept? That's why we don't have potential, but we have continuity. So when output is on, we get continuity, we don't get voltage. If you connect this SMPS, then you will get voltage. Without connecting this SMPS, there is no voltage. Okay, wiring is done. Today we can finish the things here only, because today it was too much theoretical part. After lunch, we shall go with the interface. I have already connected. I shall show you, and we shall make a project today. We shall make a project today. You have to make program for the project, and here I shall download that and will show you when how does it work. So it would be real time interface today. So if you have any question, you ask, or we shall wind up. Coordinators. Shall we stop? Okay, so we shall stop. Yes, so 1 o'clock, right? Okay. So everyone, I hope you learned something today, though it was very boring because we had theoretical part. After that, we
I
shall
just have one
main
doubt.
program. I
Maybe
shall
if you allow me, I
yeah,
can ask that.
please.
So
No
in the
problem.
last diagram, you were showing the small relay, sitting in between the common and output terminal. So is this?
Once again, just once again, please. Ask the question again, please.
Mhm. Yeah, so in the last diagram, you are showing in the output layout that a small relay is sitting in between this common and the output terminal. So does this relay
Yes.
defines what is the type of PLC, whether it is a relay type or a transistor type?
Exactly. When it is relay type PLC, all terminals will have relay. And when
Okay,
it is transistor type, all terminals will have transistor only.
transistors. Okay.
Yeah. Anyone else? Do you have question? You ask me, please. So any doubt you should not keep with you. Ask question. Have clarification. See, I also learn many things from you people. So if you won't ask question, I won't learn. Okay, fine. Then in case of input, we use sync, but in case of output, we use source. See, the thing is, you have asked here. Okay, the question is, I have just shown you that in wiring diagram, input we have sink and output we have source, but it is not fixed. Be very clear. It's not fixed that input will be sink, output will be source. Your input can also be source. It depends on manufacturer. I have used Mitsubishi PLC. The PLC today I shall use, it has sink type input, source type output. But Mitsubishi 3A PLC, another model, it had sync source input and sync output. So it can be changed also. So it is not fixed. That's why I told you check on catalog whether input is sync source, output is sync source. It will vary. Okay, done. Done. So we shall stop here after lunch, and please join at 1:50 or sorry 12:50 or 12:55 because at 1 sharp we shall start. PDF I cannot provide. That is actually that is our book, and that is on Amazon. We have agreement with Amazon. I cannot share soft copy. So please make your notes. Few things I shall share, few notes I shall share, but not that whole PDF. Thank you. See you at 1 o'clock. Sharp, please.